All right, let's solve another question. It is question 150. Let's read the question first. So a heart pacemaker fires 72 times a minute. Each time a 25 nanofarad capacitor is charged by a battery in series with a resistor to 0.632 of its full voltage. What is the value of the resistance? So first let's have a look at the diagram given. It is a power source, capacitor, resistance, and we're told it is being charged. In other words, we expect that we are starting with a charge of 0, getting to a certain voltage, and then discharging the capacitor to 0 and repeating that pattern 72 times every minute. So there's an assumption that when we discharge, it's discharging automatically. Obviously, this won't be the case, but let's keep with this assumption. Since it's charging, the charge with respect to time will be equal to the capacitance multiplied by the voltage, open the parenthesis, 1 minus exponential minus T divided by RC. All right, so let's just think about from the point of view of a capacitor. The charge on a fully charged capacitor would be equal to Q is equal to capacitance multiplied by the voltage of the battery. Obviously, we know this does not happen instantaneously. It takes a certain time. So this problem, we're told that we are not charging to the full charge. We're simply charging to 0.632 times the maximum charge. Well, if this is equal to the maximum charge, Q is equal to CV. Well, the 0.632, the maximum charge, mean it is equal to this value here. All right. Now we need to know the time, how much time it takes for this to happen. Now we are saying that it's charging 72 times every minute. So if we want to get the time, the charging time, we take 60 seconds, so 60 seconds in 1 minute. We divide by the number of time it's happened in 1 minute, divided by 72, and it's equal to 0.833 seconds in this case. All right. So basically, now we take that formula here, we replace that term with that term. So we end up with 0.632 capacitance multiplied by voltage. By the way, the voltage here, it's very important. It's not like in discharging. We are not, this is not the voltage of the capacitor itself. It's the voltage of the power source. A very important distinction, all right? So capacitance, voltage, these two, they cancel out. And we can isolate that term, we flip it on that side, we take that term, flip it on that side. Now we need to apply the natural log on both sides. So let's erase this over here. I don't think I need any of this, no. All right, so we apply natural log on both sides. All right. Natural log and exponential, they cancel out. RC is equal to ln 0.368. Might as well do this calculation right now. It is equal to -1 actually. Exactly -1. That's interesting. And we're looking for the resistance over here. So the resistance then become equal to the time divided by the capacitance. Now the time was 0.833 seconds, capacitance was 25 nanofarad, so we can find the resistance. And we got the resistance of 33.32 10 to the power 6 ohm or mega ohm, your choice. So this is the resistance. So there's a couple of steps involved. I think the most confusing one is probably the time, how to calculate the time. In a test, I will make it obvious. You won't have to guess that, okay, with discharging time, we can assume it to be 0. It's a bad assumption, obviously. But yeah, in a test, I will never try to trick you. But nonetheless, all the steps involved here are interesting. You should practice them. In the test, the question will be similar to these one. Maybe adding some, okay, what is the voltage across a resistor at a given time? We will solve such a problem in the next example. All right, so we are done with question 150. Let's go to the last example for this chapter.